Hi, this is CS22M506. I'm here recording the third part of the assignment. So unlike the first two parts, there is a length check added here. So this check is around the size of the input we enter. The size of the input cannot be greater than capital N, which is also the size of the buffer, and is set to 90 capital N. So, but if we enter any value less than capital N, this check will, uh, if we enter any value greater than capital N, this check will be executed and the program will uh, come to a halt. It'll close, right? But if we enter some value less than capital N, then we won't be able to override the buffer and inject the shell code. So the way to solve this issue is by injecting a negative value of capital N, something like -1. And we inject -1, this check will not close the program because it won't enter the if condition. And then because while we're reading, we're converting it to unsigned. -1 will become a very large value because the uh, 2's complement value, and it will become a large positive value since we're converting to unsigned, and we'll be able to override the buffer. So that's the way to go about this. Now coming to the actual shell code, the operations we need to do to bring up the shell are set RAX to 0x3b or 59, set RSI and RDX as 0, make RDI point to bin sh terminated by null character, this string, and then run syscall, right? But for the third part of the assignment, we were uh, asked to come up with uh, the shell code that only has printable ASCII characters. So based on that, the operations we can consider, we can actually use are push, pop, XR, IMUL, and move SLQ. And these are the corresponding instruction bytes, and they're all in the printable ASCII range. So we're good there. So let's go uh, through each of the operations. First one, setting RAX as 59 because 0x3b or 59 is because that's the system call number for uh, execv, right? So the way to do that is push 0x3b into the stack and then pop it into RAX. Once we do this, RAX will have this. And both these instructions are ASCII printable characters. And then we have to set RSI and RDX as 0. The way to do this is we move SLQ this into, we move SLQ this value into RSI. And then once we moved it, we XOR the same value with RSI. Since we're XORing the same value, we get 0 in RSI. We follow the same procedure for setting RDX as 0 here. Sorry. Uh, the same, uh, so both these, like all these instructions are ASCII printable characters. They can be achieved through ASCII printable characters, right? Now coming to the third part, setting RDI to point to this. So we first push this string onto the stack. What is this string? This I highlight and show you. The 2f is /. This is b, I, n, / again, s, h. So we need to terminate it with null character, but null character is outside the ASCII printable range. So I've just added 33, it's another ASCII printable character. Now we pop this into RCX. Once RCX has this value, we XOR it with this value and store the result in RCX. Why this value? Because we have so many zeros that will not affect the first 14 4-bit words, and then the last byte, right? The last 8 bits will be XORed with 33. This is 33, right? So XORing 33 with 33 will become 0. So that will give us the null byte. So now we have the entire string bin sh terminated by null character stored in RCX. Then we push RCX onto the stack, right? Now once we have pushed RCX onto the stack, we store the address of RSP, the stack pointer, onto RDI, assuming RDI is 0, XORing This with RDI is will store the value here. Right, so that's what we're doing. RCX is pushed onto the stack. So this string bin sh null character is pushed onto the stack. RSP is pointing to it, so we uh, uh, push the value of RSP here so that RDI contains the address of this string. Again, all these instructions are implemented through ASCII printable characters. The final thing is run syscall. So to run syscall, we push this onto the stack. Then we move this into RAX. And then once we have this in RAX, we XOR it with the string and store the result back in RAX. This because we're XORing these two numbers. So it's 40405. They're all the same characters. So XORing these two will be uh, 0 essentially. So we could have skipped it also adding these. But yeah, anyway, so 575A. And the last four characters here are 5255. So 5 and 5 will XOR to be 0. 7 XOR with 2 will give us 5. 7 XOR with 2. The 5 XOR with 5 will give us 0 again. A XOR with 5 is F. So we have uh, 0, 0, 0, uh, uh, 0, 5, 0, F, right? And when you push this onto stack, it becomes 0, F05. And that's the instruction we want to push onto the stack. So we've done this. And all these instructions are again ASCII printable characters. So we were able to achieve all the four using ASCII printable characters only. So we were able to uh, pass the length check and come up with a shell code that only contains ASCII printable characters. Thank you.